Welcome back, algebra students. Today's lesson is going to focus on the properties of real numbers. And these are properties you're going to see consistently throughout all of your algebra and other math courses throughout the high school. So it is important to get to know them as soon as you can because they will follow you through the next few years of your math careers. First one we're going to talk about is the commutative property. It's called commutative because of the root word within the property's name, which is commute. Very similar to me talking to you about commuting back and forth to school. Most of you will recognize that what I'm really referring to is the amount of time it takes you to move from home to school, and then again back to home from school at the end of the day. The commutative property works in algebra as well in two different forms. The commutative property addition allows us to add values in any order we want. So if you don't like the way a problem is presented to you as far as the order of things being added, feel free to move them around as long as it's only addition in the problem. The commutative property also holds true for multiplication in the same way. You can move things around in a problem and multiply in a different order if it's easier for you, as long as the problem is only referring to multiplying values. The next property we talk about is associative property. And this is very similar to associating with the people sitting next to you. So as you see here in this top line, we've got our two people, green and pink, talking to each other. So I'm going to put them in a group, all right, of discussion. Unfortunately, we have our sad little green fellow at the end. So if this would be associative with addition, you might see a plus sign with our two. And then outside of the group, we're still going to include the green in the overall class. However, he is not one of the associates. In the bottom line, we have a very similar idea here. Green and pink are now the associates. And we've got our first sad little fellow here outside of the associating group, but he is still part of the class. So if you notice here the associative, you're going to always be seeing two or more members in parentheses, and you're going to be seeing somebody else left out of the associative group. But this is identified as the associative property. The associative property of addition. We can group terms in any way. This is just like that first set of people talking. The associative property of multiplication works in the same way. If we're talking about multiplying, we can group any terms we'd like together and leave out a couple for the end if that is easier for us to solve. And throughout your homework, you're going to be seeing problems using these properties. The next property we're going to talk about is the identity property of addition. And the identity properties, both of these, want you to focus on getting back what you started with, or in other words, maintaining the identity of the value. So for the identity property of addition, the magic number is going to be 0, because any number, when you add 0 to it, gives you back the exact same value you started with. So for example, I have here 3 plus 0 equals 3. And again, this one is usually common sense to most people, but it is a rule for algebra, so we do always include it in the properties. Similarly, the identity property of multiplication, this is the same concept, but the magic number is going to change to a 1, because 1 times any number gives you back the number you're starting with. So we can just pick any number here, let's say 12, and if I multiply that by a 1, the identity property of multiplication tells me I'm going to get back a 12 for my answer. So the properties, hopefully you're going to be seeing, is a way of validating your answer, all right, which is going to come in handy later on when we get to algebraic proofs, but we don't need to worry about that this time. Next property, the inverse property. An inverse, a lot of people will think is opposite, all right, which can help you in this aspect of the inverse property of addition. The inverse property of addition basically says to negate the number and add to get 0. Your focus in the inverse property is you want to get 0 as the answer. So here's where this idea of opposite can help a lot of people here. For the example, 5 plus what equals 0, you want to start thinking opposite. Opposite of 5, I'm hoping everybody at this point is saying -5. And it's easy to see on your calculator or just by hand, a 5 plus a -5 is going to give us a 0 as the answer. The inverse property of multiplication, here's where it gets a little bit different. It's not quite opposite. You want to flip the fraction and multiply to get 1. Right? Just like with the identity properties, 0 was the magic number for addition and 1 was the magic number for multiplication. Same idea here, it's just that 0 and 1 are now our answers. So for the example given, 5 times what equals 1, we're going to flip the fraction. So 5 is the same as 5 over 1. So we're going to multiply that 5 times its flipped over, 1 over 5, or the reciprocal, for those of you that remember that terminology. Okay, so in this case, example 5, I'm asking you to name the multiplicative inverse. All right, so for a 5, the multiplicative inverse, you need to think about inverse here. 5's multiplicative inverse, everybody should be flipping that upside down, 1/5. 2/3 multiplicative inverse, again, flip it upside down. If we're talking about the inverse property with multiplying, you always want to get into the habit of taking the number and flip it upside down. For the bottom half, now name the additive inverse. All right, so again, adding, inverse, you want to think of 0. So what can we put with the 5 to make it a 0? And that would indeed be a -5. What can we put with the 2/3 to make it 0? Again, -2/3 because we're adding here. Now I skipped the x in the middle, all right, but what I want you to see is in algebra, all right, it doesn't always have to be numbers. We're going to get comfortable with working with variables as well. So first off, the multiplicative inverse of x, well, this is simply going to reverse it. 1 over x would be the multiplicative inverse. We can still flip that x value upside down. The additive inverse, here's where we focus on the opposite, and we're just going to put a negative sign in front of the x. And you can read that as a -x or the opposite of x, either way you like. Okay, so let's test your knowledge between the identity and the inverse property, just to make sure you've got it. All right, first I have here a 3 plus 0 equals 3. Is this identity or is this inverse property? Well, I see that I'm starting with a 3 and ending with a 3, and I believe that is identity property, and I'm absolutely right. Next up, we have a 2 plus a -2 equals 0. I'm not getting the same value back, but I do notice that I am adding opposites or inverse, so we're going to drag that over into the inverse vortex. And we can just pick a couple others here, just to be sure. Here I see a 4 times 1/4 equals 1. Again, I'm not getting back the same thing, so I'm not dealing with an identity here. I must be dealing with an inverse property. Okay, let's move on. Multiplicative property of 0 and the multiplicative property of -1. These are some, again, They tend to make sense right away, but it is a way of validating an answer, which you are going to start to get into the habit of doing. Multiplicative property of 0, simply this. Anything times 0 equals 0. A nice, easy one for us. Multiplicative property of -1, very similar. Anything times -1 equals opposite. Of the given. Again, another pretty easy property for you to recognize and use. Okay, so let's try a couple of these. Let's match the example to its property. Now the distributive property, all right, this is something that we didn't exactly mention in this section here, but let's see if we can figure that one out on our own. So we're going to save that for now. All right, identity of multiplication. Identity, multiply. Pause here, see what you think. Okay, so identity properties. This is where we want to get back what we started with. And we're multiplying here. So what I notice is in my third option, I'm starting with a 2x. I'm multiplying it by a 1, and I'm getting a 2x back. So I started with a 2x, I end with a 2x. This must be identity of multiplication. What I'd like you to do from here is pause the video, try and match these up on your own, compare them to your notes. Bring them into class tomorrow and check with your teacher. I will help you with the distributive property before we leave this page. Distributive property is simply this. You want to look for a group and you want to look for one value outside of the group. That single value outside of the group will be multiplied through the group members. And right here is your distributive property. 1/3 times the quantity 2x minus 6 equals 2/3 x minus 2. We'll focus on this property a lot in another lesson as well. So the last set of examples here, we're going to name the property that each equation illustrates. Letter A, we have 1 times an m equals an m. And hopefully at this point you're seeing multiply by 1, getting back the same thing. This is definitely identity of multiplication. Letter B, we have -3 and a +4 grouped together on the left side. We have a +4 and a +5 grouped together on the right side. That's the only difference, and the group members have changed. So in other words, this is like the people talking in our class. This is the associative property of addition, because it's all addition in the problem. Letter C, 2 plus 0 equals 2. Again, starting with a 2, ending with a 2. You should already be screaming, identity property. And this is identity property of addition this time. Letter D, we have a 3 outside, 8 times 0 in the group. On the other side of the equal sign, we have 3 times 8 in the group and times 0 outside of the group. The group members have changed, or the associates have changed. This is the associative of multiplication. Letter E, P plus Q, Q plus P. Same problem, reversed order. We moved things around, or in other words, this is the commutative of addition. Letter F, very similar, N times P, P times N. All we did was move things around. This is the commutative of multiplication. Okay, so at this point, we've gone through each of the properties you'll be working with. Try the homework. If you have questions, come see your teacher. Good luck.